Good afternoon students. Welcome back to online mathematics class. So in the last class we have solved up to the 18th question. Let us continue with the 19th question. The given question it is, find the sum of the products of the corresponding terms of the sequences 2, 4, 8, 16, 32 and 128, 32, 8, 2, 1 by 2. So here he says the sum of the products of the corresponding terms. Corresponding terms means 2 and 128 are the corresponding terms, and then 4 and 32, 8 and 8, 16 and 2, 32 and 1 by 2. These are the corresponding terms. We have to take the sum of the products. So let us go ahead with the solution. Required sum is equals to 2 into 128 plus 4 into 32 plus 8 into 8 plus 16 into 2 plus 16 into 2 plus 32 into 1 by 2. 32 into 1 by 2. So see here, I have taken the sum of the products of all the corresponding terms. So simplify this. So this is equals to 256 plus here we get 128 plus, so it is 64, then plus 32 plus 2 ones are 2 16s, we get plus 16 here, and then so here we have 5 terms and this is a geometric series. This is there in the GP. So here the first term is 256 and then the common ratio is going to be 1 by 2. A2 by A1, 128 divided by 256 or 64 divided by 128. So here A which is equals to 256 and then R which is equals to 64 by 128 will give us 1 by 2, which is less than 1. Therefore, the formula is going to be Sn which is equals to A into Sn equal to A into 1 minus R raised to n divided by 1 minus R. Then Sn which is equals to, that is the sum, or you can write only capital S, the sum. A, what is A? It is 256. And then 1 minus R raised to n, that is 1 by 2 raised to n. N is nothing but 5 here, that I will be writing here. N equal to 5. So here I will replace n by 5. So sum of the 5 terms 1 by 2 raised to 5, then divided by 1 minus R. R is 1 by 2. So now S5 which is equals to 256, then here we get 1 minus, this power applies to the numerator as well as to the denominator. 1 raised to 5 it is 1, so you get 1 minus 1 divided by 2 raised to 5, that will be 32. So now here 1 minus 1 by 2 it is 1 by 2. So now this 2 goes to the numerator. So here S5 which is equals to 256 into 2 inside the bracket, take up the LCM now. 32 will be multiplied with the, you get 32. 32 minus 1 divided by 32. Then S5 which is equals to, so how much we get? 256 into 2 will be 512, then into 31 divided by 32. So here cancel out 512 and 32. So you get 16. So S5 which is equals to 16 into 31, it is 496. It is 496. Therefore, the required sum is going to be 496. This is all about the 19th problem. Well, the 20th question, it is, show that the products of the corresponding terms of the sequences A, AR square, so on, A into R raised to n minus 1, and he has given another sequence, that is AR square, A into R raised to n minus 1, form a GP and find the common ratio. See here, he says, show that the products of the corresponding terms. What are the corresponding terms here? Small a and capital A are the corresponding terms, and small ar and capital AR, these are the corresponding terms. So we have to take the product of the corresponding terms and we have to show that product is going to form a geometric progression, and we will have to find the common ratio. So here it has to be proved that the sequence I'll write the sequence now. A into capital A, AR into capital AR, and then next term it is A into R square, here capital A into capital R square, and so on. Like this it continues. A into R raised to n minus 1, here capital A into capital R to the power n minus 1, form a GP. Form a geometric progression. If the terms or sequence is a geometric progression, then the ratio must be common, that is the ratio must be same. A2 by A1 should be equal to A3 by A2, that should be equal to A4 by A3. Second term divided by the first term is equals to third term divided by the second term. So here I will go for second term, or directly I will take A2 by A1. So here he has used small a and capital A. Let us not write this, write in words. Second term divided by the first term, which is equals to, what is the second term? AR into capital AR divided by A into capital A. So now small a get cancels, capital A get cancels, so it is R into capital R. Then now I will go for third term divided by the second term. Third term divided by the second term. What is the third term here? It is A into R square and capital A into capital R square. A R square and then A into capital R square divided by second term. It is AR capital A R. So now which all term get cancels now? Small a, capital A and then capital A, and then here small r and one small r get cancels, capital R and here one capital R get cancels. We have R into R here, small r into capital R. So observe the ratio here, it is the same. Therefore the common ratio is equals to small r into capital R, and hence this sequence, hence above sequence forms a geometric progression. Hence the above sequence forms a GP, forms a GP. So this is all about the 20th problem. Well, the 21st problem, it is find 4 numbers forming a GP in which the third term is greater than first term by 9 and the second term is greater than the fourth by 18. So we'll write the given information and we will have to find the first 4 terms of a geometric progression. That's what the question is. Find 4 numbers forming a GP. So here given, so it is the third term is greater than the first term by 9, A3, which is equals to greater than the first term by 9 means A1 plus 9, A3 which is equals to A1 plus 9. This implies, what is A3? It is A into R square, which is equals to A1 is nothing but A. First term can be written as A or A1 plus 9, call this as equation number 1. So now, and what is the other condition? And the second term is greater than the fourth by 18 and A2 which is equals to greater than the fourth, A4 plus 18. This implies second term is nothing but A into R which is equals to fourth term will be A into R raised to 3. A into R raised to 3 plus 18. Call this as equation number 2. So now from 1 and 2 we get 2 more equations. I will take A to the left hand side and A into R cube to the left hand side. From 1 and 2, equation 1 and equation 2, what do we get now? A R square minus A which is equals to 9, Then I take A common here, we have R square minus 1 which is equals to 9. Call this as equation number 3. And from this take A into R cube to the left hand side and AR minus AR cube which is equals to 18. Again we have A common here. AR common. We have 1 minus R square which is equals to 18. This is the equation 4. Now we have to go for equation 4 by equation 3. So here equation 4 by equation 3. Equation 4 by equation 3. What is the equation 4? It is AR 1 minus R square divided by A into R square minus 1 which is equals to 18 by 9. So now A and A get cancels. So I will take minus 1 common in the denominator. So here R into 1 minus R square as it is. Then if you take minus common in the denominator, the terms will be reversed. So we get minus 1 minus R square which is equals to, so here it is 9 ones are 9 twos are, we get 2 here. Then 1 minus R square and 1 minus R square get cancels. R by minus 1 it is minus R. Minus R equal to 2 or R equal to minus 2. So here the common ratio it is minus 2. Substitute this in equation number 3 or equation number 4 to get the value of A. So put R equal to minus 2 in equation 3. So now A into R square, that is minus 2 the square will be 4, then minus 1 which is equals to 9. Then A into 3 is equals to 9. Then 3, take it to the RHS, it goes to the denominator. A which is equals to 9 by 3. So A which is equals to 3. 3 ones are 3 3s are. So we have the first term and the common ratio. We will have to find the first 4 terms of the GP. Therefore the 4 numbers of a GP are A, AR, AR square, AR cube. A it is 3. Then AR, that is 3 into minus 2. Then A into R square, 3 into minus 2 square, and then AR square, then AR cube. Then A it is 3 into minus 2 cube, that is 3 comma minus 6, and then minus 2 square will be 4 into 3 it is 12, and then minus 2 cube it is minus 8 into 3 will be minus 24. So these are the 4 numbers of a given GP. So this is all about the 21st problem.